All right, so today we're going to learn about the pattern of quadratic functions, meaning what is the pattern that we use to build a table. So with linear functions, we used delta y over delta x. So if I knew that the slope was 3 over 1, then that meant that if I had a row that started with 1, 5, I could add 3 to x and 1 to y to build the next row. And I could keep on doing that to build out the table. That's how we built our tables that were linear. Quadratic tables are going to be a little bit different. Okay, so first of all, we need to review. Vertex form is y equals a times x minus h squared plus k. Now this is on your formula chart. You don't have to memorize it. But we are going to be using that a lot for the next several days, so you kind of got to keep it in our brains. Also, the vertex is hk. So that means whatever is here, so like if it says x minus 3, then the h part of my vertex is plus 3. If it says x plus 5, then the h part of my vertex is minus 5. So whatever I see right here, I'm going to take the opposite of that and put it into my vertex. K is exactly what it looks like, so I'm not going to make any changes to k. So k just stays exactly what it is. If you see minus 5, I put minus 5. If I see plus 3, I put plus 3. Okay? So that doesn't change at all. Now, the pattern. The pattern for quadratics is different, okay? So if I have a pattern for quadratics, first of all, I start in quadratics, I start at the vertex. So whatever the vertex is, and I always put the vertex in the middle of my table. So let's say my vertex, let's say this is the function I have, y equals, and this, let's look at the first one on your paper. Let's look at the first one on your paper. Y equals x squared. Okay, so y equals x squared. Okay, so when I look at this, this is the parent function. The parent function goes through 0, 0. I could rewrite this filling out vertex form. I have an invisible 1 in front. That means A is 1. I have kind of invisible parentheses there, but I'm not adding anything because I'm not shifting left or right. And I'm also not shifting up or down, so I'm not adding anything. So I could expand that out to get my vertex. Okay, this is my H, and this is my K. Okay, well the opposite of 0 is 0, the opposite and 0 is 0, so my vertex is at 0, 0 on this function. And again, this one is already done, that's why I'm just kind of talking you through it. Now, to build out my table, I'm always going to add 1 over here. Over here, I'm going to add the number I am away from x. So this is the first jump, right? So I'm going to add 1 squared times a, which in this case is 1. So 1 squared is 1. 1 times 1 is 1. So I'm adding 1. Okay? For the second hop, I'm going to do 2 squared times 1. So 2 squared is 4. 4 times 1 is 4. 0 plus 4 is 4. Okay? For the third hop, since I'm 3 away, I'm going to add 3 squared times 1. Well, 3 squared is 9. 9 times 1 is 9. Okay? So the pattern is the number of hops away squared times a. And in this case, a is 1. All right? And then I can just back build my table, right, using symmetrical pairs, right? Well, I know that if there's a 1 here, there's got to be a 1 there, a 4 there, a 9. I continue this pattern going backwards, just like we did before. Okay? So let's try one that looks a little different. All right, first of all, what's going to be different about this? So that was just this first one that they gave you, and we can plot that graph. We can graph it any time. Okay? Now, let's look at this parabola. Let's look at this one. This one is x squared, x minus 3 squared plus 4. So first thing I had to do is I got to write h, k. Okay? Well, this is negative h and k. So what's the opposite of negative 3? Positive 3. And 4, I just write down exactly what I see. So my vertex is 3, 4, which is over 3, 4. It's right here. Okay? Now, first I'm going to add 1 squared times 1, because there's nothing there. So 1 squared times 1 is 1, times 1 is 1. 4 plus 1 is 5. So there's a 5 there. There's a 5 here. Okay? So I have a point at 2, 5, point at 4, 5. Looking like a parabola so far. Next hop, it's the second hop, so I'm going to add 2 squared times 1. 2 squared is 4. 4 times 1 is 4. 4 plus 4 is 8, so I'm going to have an 8 here and an 8 there. So I would go over 5 up 8. Wait, where'd it go? It was 8, right? Yeah. Wait, okay. And I got a point there. This is definitely looking like a parabola. The last one, I'm going to add 3 squared times 1. 3 squared is 9. 9 times 1 is 9. 4 plus 9 is 13. So over 0 up, we're just kind of eyeballing it at this point. But this is absolutely looking like a parabola. Okay? Let's look at the next one. This last one is a little trickier because this time we do have an A. So again, we start by identifying our vertex. What's the opposite of plus 5? Minus 5. The 4 we leave exactly as it is. So my vertex is at negative 5, 4. So I go back 5, up 4. Okay? Now, I'm going to fill out the x, so it's going to be negative 6, negative 7, negative 8, negative 4, negative 3, negative 2. Again, I'm just filling out the x's. Now I'm going to fill out the y's. So my first hop is plus 1 squared, but I have an a now, so I'm going to do times 2. So 1 squared is 1, 1 times 2 is 2, so I'm going to do 4 plus 2, which is 6. I'm going to have a 6 here and a 6 there, so I'm going to go over 6 up 6 and over 4 up 6. Yeah, and it looks like it's stretched, just like we would expect to see with this. Now I'm going to add 2 squared times 2, because I have this 2. 2 squared is 4. 4 times 2 is 8. 4 plus 8 is 12. So now I'm going to go over 7 up, well, we're going to have to eyeball this, up 12, and over 3 up 12. And I really am not going to be able to get any further than that on the graph, but we'll go ahead and do it here. Since it's the third hop, I'm going to do 3 squared times 2. 3 squared is 9. 9 times 2 is 18. 4 plus 18 is 22. So I would go over 8, left 8 up 22, left 2 up 22. All right? This is the pattern. We will practice this more in class tomorrow, and we will also learn something else in class tomorrow.